Okay, so in this case, we've got magnesium chloride. So we've got MgCl₂.xH2O, and we've got the mass of that hydrated magnesium chloride at 11.27 grams, right? And just for clarity, as the disclaimer mentioned, some of these examples, the actual end results are just for the purpose of examples on it's more about the method as opposed to necessarily being a representation of a realistic or likely hydrated sample, right? But anyway, that's all been explained. So okay, so in this particular case, the mass of the sample was found to be in the anhydrous form 4.97 grams, right? So we effectively need to work out the value of x in this question, and you know, the real question here is, well, for every 1 mole of MgCl₂, how many moles of H2O are there gonna be? That's really what x is telling us. So to work this out, I'm gonna try and figure out what the number of moles are for MgCl₂, the moles for H2O, and then do some comparisons from that point going forward as far as the ratio. So if I want to work out the number of moles of magnesium chloride, the general formula which is going to be useful here is that the number of moles N is equal to the mass M divided by the molar mass Mr, right? And we have the mass M, so in this case, the number of moles of MgCl₂, as far as the mass M, is going to be equal to 4.97, right? But then that needs to be divided by the molar mass Mr. Now for Mr, we're going to need to work that out from the periodic table. Okay, so that's going to be 24.3. Okay, so as you can see for Mg, so yeah, 24.3. Plus, and then for the Cl2 component, that's going to be 35.5 Cl2, so that's going to be it's going to be times 2, right? And that's going to give us 95.3. Okay, and in this particular case, we can say that the Mr of MgCl₂ in Cl2 in this case is 95.3 grams per mole, right? So that's the units for it. Yep. Okay, so yeah, so that would effectively mean that here we're going to have 95.3, right? And that's going to give us the number of moles of the MgCl₂, which in this case is it's going to be 0.052151, right? So that's what it's going to be to 5 significant figures. And at this point, we can look into working out the number of moles for the H2O, right? And this is going to be in moles, right? So for H2O, although it doesn't explicitly tell us what the mass is, if we take the 11.27, which is the hydrated mass, right? So 11.27 grams. And if we subtract from that the anhydrous sample mass, which is effectively the sample mass which is contributed to by the MgCl₂ component, right? What we're going to be left with, of course, is going to be the H2O aspect. So minus 4.97 grams, right? That's going to be 6.3 grams, okay? Now, with the 6.3, we can say that the number of moles of H2O is going to be equal to 6.3 divided by, and then the Mr of H2O. Now, in this case, the Mr of H2O is going to be, so we can work this out, it's got hydrogen here and oxygen, is going to be 1 times 2, so this is the hydrogen aspect, plus 16, which is the oxygen aspect, is going to be 18, right? So the MR of H2O is equal to 18 grams per mole, right? Now, given we've got that value, we can then say, okay, well, 6.3 needs to be divided by 18, okay? And if you do that, what you should get is that that's going to be 0.35, okay? And that's going to be in moles. Okay, so we've got now the moles of the MgCl₂ and of the H2O. And the question really is here, well, how do we need to kind of compare them, right? So what I'm going to do, because MgCl₂ is on the left hand side here, H2O is on the right hand side, I'm going to put MgCl₂ on the left hand side. So we're going to say MgCl₂, the number of moles of that compared as a ratio to the number of moles of H2O, right? And of course, on this side, that's actually going to be what we worked out here. So it's going to be the 0.052151, and the ratio that's going to be compared as to 0.35, which is the H2O aspect, right? And remember the question again, it's going to be, the question really, what X is really trying to answer is, if we have 1 mole of MgCl₂, how many moles of H2O are we going to have? But to truly trying to approach and address that question, we want to get the moles of MgCl₂ to be 1, right? So and the way to do that in this particular case would be to divide it by itself, right? So if we divide this by itself, we're going to get 1, right? So divide that by 0.052151, right? You're going to get 1, right? But here's the thing: we also, if we've done that to the left hand side, because it's a ratio, what you do to the one side, you also need to do to the other side. So we're going to also need to divide this side by the same. So 0.052151, okay? And if you do have a go, work this out on a calculator, you should find that you get 6.7113, right? To 5 significant figures. And well, we were looking for an integer value, right? So we have, it's, we want to round this to the nearest integer to achieve that. So in this case, the nearest integer is 7, right? So we need to round it up to 7. So we're going to say, well, 1 is actually the ratio of the MgCl₂ to the H2O is approximately 1 to 7, okay? And therefore, we can say that X is equal to 7. Now, if X is equal to 7, then we can say that the formula is going to in effect be MgCl₂ dot 7 H2O, okay? So we can just put a 7 here as well, right, to kind of represent that. So yeah, so X is equal to 7 in this case, all right?